So now that we've finished up our unit on the periodic table, we're going to start applying what we've learned about the elements and see how they start to interact with one another when they come together. And to get an introduction into how this all works, we need to take a step back and consider how elements exhibit both physical properties and chemical properties. And those all are based on our observations that we make about them. So when we discuss physical changes, this is just talking about changes in appearance only. This is only talking about the your five senses and how you can make observations using your senses, like taste and touch, smelling, sight, and hearing. So no new substance is formed when a substance undergoes a physical change. It just looks different, or it has that different sense to it, but it's still the same substance altogether. So some examples of physical changes include tearing or folding paper. So you're not changing anything about the paper itself other than its appearance. Phase changes are also physical changes. So ice melting or water freezing, water evaporating or water vapor condensing, it's all still made up of water molecules. So if we get down to the individual molecules, we would see that they're all still 2 hydrogens and 1 oxygen attached to each other. But the only difference that makes it change phases is how far apart they are and how fast they're moving. Finally, another example could be like crushing or opening a can. So all of these examples, again, they're not changing anything about the material itself, but it's just changing maybe the shape or the appearance of the material. Okay, chemical changes is the other type of change that matter can undergo. And this is a change through a chemical reaction, and it produces a new substance altogether. These new substances are made up of all the same elements that came from the original substance, but the atoms are rearranged. So there are several different situations where compounds could be formed from 2 individual things. They could be rearranged, so kind of like they're shuffled up, or they could be broken down into the individual pieces. So, for example, we've got several different reactions here. We've got the compounds, we're trying to figure out if they're being formed or rearranged or broken down, and sometimes they could be a combination of several of these. The first one is iron and oxygen. When they come together, this little arrow that you see here represents kind of like an equal sign, like if I put these 2 things together, then I get this other thing. And so when we read this in science class, we're going to say the word yields for the arrow. So when I put iron and oxygen together, they yield iron oxide. Another word for that is rust. Okay, so when I put the 2 individual elements together, when they're exposed to each other and there's a chemical reaction, which is implied by the arrow, I end up with rust. So this is a formation because I'm taking these 2 individual elements right here and I'm putting everything together into one compound. Our second example here is silver sulfide and aluminum. And when I put those 2 things together, I end up with silver by itself and then aluminum sulfide. So you can see that we've had a bit of a rearrangement here. It looks like silver and aluminum have switched spots. Okay, so because they have switched, they are rearranging themselves in the end. So that's how we get rearranged. Finally, I've got carbon dioxide and water in the sunlight. When they all come together and react, I end up with oxygen by itself and glucose and water. And so hopefully this seems a little familiar to you. This is actually the chemical formula for photosynthesis, this whole process that takes place that allows us to breathe oxygen. So first you should see that this oxygen is all by itself at the end. So that means it has broken off from these compounds over here. Okay, and once it's broken off, we then have a little bit of rearrangement with the carbons and hydrogens and leftover oxygens. So in this case, because it's such a long formula, several things are happening with the different compounds. So this is just an example of different types of chemical changes that could take place in nature. And then some other common chemical changes that you might see involve burning or combustion. So you're really not going to get the original material once it has been burned. So think of like a fireplace in the winter. All the ash is not going to turn back into wood. It doesn't resemble anything like what it did before. Rusting is the same idea, as is tarnishing. Tarnishing is like this picture with the silver in this bottom right-hand corner. Digestion, photosynthesis, and decomposition. These are all examples of changes that take place to the point where you cannot, the end result does not resemble what you had at the very beginning. And so in class, we'll do a couple of other examples of things that you might see in everyday life, and you'll help me identify which type of change it demonstrates. So finally, just to give you a little bit of practice before we do that, you have to identify these chemical or physical changes here. So a piece of metal being bent, all you're doing is changing the shape of the metal, so that's an example of a physical change. Now, a bracelet turning green, this is like if some of you females, I don't know, some of you guys too might have had a bracelet or a necklace that you might wear, and if it's not made out of like sterling silver, for example, if it's like a cheaper version, a lot of times like the fake jewelry will turn a certain color, or it might even turn your skin a certain color, so that's a chemical reaction. A plant making its own food, that's photosynthesis, that's chemical. An apple rotting is decomposition, that's chemical. And then hair being cut. If you cut hair, all it's doing is changing the length of it. It's not changing the fact that it is hair. And so that is a physical change. Something that can kind of give you a clue for when we're doing these changes in class. There are 3 things to keep in mind if something is an example of a chemical change taking place, or of a sign of a chemical reaction. First, if you are not adding heat, but it still bubbles up, so there's still a gas being formed, that's one sign. Another sign is a color change without actually adding pigment to it, like putting paint in it. And then the third sign would be temperature change without physically putting it onto a heater or in the refrigerator or something. So when we're in class, hopefully these things, as you keep them in mind, it'll help you be able to identify what type of change is taking place when we do this as a demonstration.